Alright, so we got problem number 38 right here. And the way we want to go about solving this is finding a common denominator. So what you're going to notice here is if I take this piece and multiply it by the top over here, and I take this piece and multiply it by the top over there, you'll see that we have conjugates. Alright, after I multiply the top times the denominator of the other side, and they were conjugates, then I have the difference of perfect squares on top of both of them. Now, when I look at the top, I need to reorder, because it looks to me right away like if I include my cosine squared plus my sine squared, that's going to make life really, really good for me. So on top I have cosine squared of x plus sine squared of x, and we all know what that equals. And then if I look at my other one, I have minus cosine squared of y, and then minus again sine squared of y. Now, the great thing that we can do right here is we can factor out a minus. So I can subtract cosine squared of y plus sine squared of y. Now, what does that do for me? Well, cosine squared plus sine squared is equal to 1, and cosine squared plus sine squared is equal to 1. So, what is 1 minus 1? 0. That's a really hard proof. If you know how to do that, you guys are doing sweet. Alright, so now we can look at 51. If you see, on the left side I have 2 things to the 4th power. In my identities, I don't have many identities to the 4th power, so we notice it's a subtraction sign, so it's a difference of perfect squares. So let's rewrite this left side. I have secant squared of theta plus tangent squared of theta, and then I'm going to have secant squared of theta minus tangent squared of theta. Now, that really allows me to do some really good stuff, because if you look back at your ticket, are any of these identities? I think so. I think secant squared minus tangent squared is just going to be equal to 1. So that leaves me with secant squared of theta plus tangent squared of theta. And if you don't know what to do right now, we can look back at the original problem, and what is the only trig function on the right? Tangent. So let's do a substitution. Can I substitute in for this secant squared? Sure. I can rewrite that as 1. I can rewrite that as 1 plus tangent squared of theta. That way, when I add the original tangent squared of theta, I'm right back to where I started. 1 plus 2 tangent squared of theta. And we have verified it. Alright, number 48, I'm actually not even going to do, because if you look back on some of the work we did in class, we have this exact problem, or one very similar to it, in class. So take a look back, and make sure you know how to do that. 45, I'm going to let that be my big challenge problem. Can't wait to see who comes to class with that one done, or almost done, and I want to see what that looks like. So we can take a look at number 39. I think this is the last problem I'm going to help you guys with, but I saw a student today take both sides and square them. Okay, that frees up the left side. And then remember, I have to distribute that squared to both pieces. So I have 1 plus the sine of theta squared on top, and on the bottom I have cosine squared of theta. Now that should start to look really, really good for us. If I look just at the right side, that's 1 plus the sine of theta and 1 plus the sine theta. I'll try and stick it in there, or fit it in there, and then cosine squared is 1 minus sine squared of theta. So it looks like we're very, very close to the left side. The only thing we have left to do is we want to fix the denominator. So if you notice, it is the difference of perfect squares. 1 minus the sine squared of theta is the difference of perfect squares. So I can rewrite that. My denominator is going to look like this. 1 plus the sine of theta and 1 minus the sine of theta. How is that going to help me? Well, if you look up at your numerator, I think we'll be able to cancel out one of each. So I can get rid of that, and I can get rid of that. And that leaves me with the same thing I had on the other side. 1 plus the sine of theta and 1 minus the sine of theta.